Good morning, good afternoon, or good evening, and welcome back to Three Inquisitive Kids. In this lesson, we will be looking at the application of linear functions. The spotlight of this lesson is to really apply the information we learned from the previous lessons and apply them in actual word problems. Chapter 4, Solving Word Problems Using the Graphs of Linear Functions. As you can see in the course outline, this is part 2 in our final lesson of applying linear functions. If you would like to be notified when we upload the last and final lesson of the unit, please make sure to go down, click the subscribe button as well as the notification bell. That way, you will be notified when we upload that lesson. Anyway, here are our learning goals. Master the application of the graphs of linear functions and to understand the relationship between linear functions and linear equations in one variable. As you may remember if you have watched our previous videos, linear equations in one variable is a topic we have touched on in previous chapters. Introduction. Review and think. What types of information can be obtained when you look at the graph of a linear function? So it's also asking, once you're given the graph of a linear function, what values can you immediately find? Well, you can find 4 things. First, you can find the signs of k and b. K in here is the slope. So this is according to the form, the linear equation form, y is equal to kx plus b, where k and b are the constants. K is the slope, while b is the y-intercept. So that means the y-intercept can also be determined. You can also find the slope of the function, which is also k. So the slope is the speed at which the function increases or decreases. You can find the corresponding values of x and y. If you trace your finger along the graph, any point that your finger stops at will have both an x value and a y value, an x coordinate and a y coordinate. Those two coordinates are a coordinate pair. Now we're going to get started in applying graphs of linear functions. Due to continuous high temperatures and no rain for days, the amount of water in a reservoir decreases with time. A reservoir, for some background information, is just a place where they store water. The relationship between the amount of existing water in the reservoir, V, which is 10,000 meters cubed, that's its unit, and the drought duration, T, in days, is shown in the figure. So out of looking at this graph, I want you to answer the following questions. First, what was the amount of water in the reservoir when the drought began? And the answer would be 1,200. And how did we get that answer? Well, when the drought began, that would be when there was 0 days. That would mean when t is equal to 0, since it's at the very beginning. In this case, we can trace to the point where x is equal to 0, in other words, the y-intercept, and we see it has an amount of water in 1,200 million meters cubed. Here we just wrote 1,200 for simplicity. I think you might get it, but when you're solving an actual question, say on an exam or a test, you need to make sure you include the proper unit. And 2, by the time the drought had lasted for 10 days, how much water is left? What about 23 days? Well, for 10 days, you trace when t is equal to 10, since t is equal to the amount of time the drought has lasted, and then you find its corresponding y value, which in this case is 1,000. So that point right there, you would answer 1,000. And for this point, which is about 23, we don't know what is the y value corresponding to this x coordinate. Answer the following questions. When the amount of water is less than 400 million meters cubed, a severe drought alert will occur. So once it's at this point, this reservoir will automatically have a drought alert. After how many days of drought will a drought alert be issued? And 4. According to this pattern, or this equation, how many days is it expected that the reservoir will dry up completely if the drought lasts? The answer to the first question would be 40, because right here, when it is less than 400 million meters cubed, that would be anywhere below this point. This is the point that a drought alert will occur. And this happens when there are 40 days into the drought. So the answer would be 40. Again, make sure you include the unit. The answer to number 4 is 60 days, because if it continues according to the same pattern, it would take 60 days in order for V to equal 0, in order for the amount of water in the reservoir to be equal to 0 million meters cubed. Example 1. After a certain motorcycle is filled with fuel, the relationship between the remaining fuel volume, Y, in liters, in the fuel tank and the distance driven, X, in kilometers, of the motorcycle is shown in the figure. So this is the function that represents the relationship between X and Y. First, how many liters of fuel can the fuel tank store? I want you to pause the video and see if you can answer this question. By looking at the graph, we know when x is equal to 0, y is equal to 10. This also means how much fuel is in the fuel tank when you do not travel any distances. It's just saying the full capacity of this fuel tank. So then you look at where x is equal to 0, you know y is equal to 10. Therefore, the answer would be 10 liters. How many kilometers can the motorcycle travel on one full fuel tank? The answer you should have gotten is 500 kilometers. What this means is when it says how many kilometers can it travel, so until it runs out of fuel, which means that's x is equal to y is equal to 0. So find the point where y is equal to 0, and over there x is equal to 500. So the answer is 500 kilometers. How many liters does a motorcycle consume per 100 kilometers? This is a velocity question. Now this is a bit more complicated because it requires more calculation. So as x increases from 100 to 200, 100, I'm going to draw a point right there, 100 to 200, right? Y decreases from 8 to 6, so from 8 to 6. Since it decreased by 2 since y decreased by 2 as x increased by 100, we know the motorcycle consumes 2 liters every 100 kilometers. When the remaining fuel in the fuel tank is less than 1 liter, it will automatically alert. How many kilometers will be traveled until the motorcycle auto alerts? So when it says less than 1 liter, this tells us it is talking about when y is equal or less than when y is less than 1 liter. We know that there's a point where y is equal to 1. We know x is equal to 450. So after traveling 450 kilometers, the motorcycle will alarm automatically. Conclusion. How do you solve the information of the actual this part does not make any sense. How do you solve information from the direct function graph? Well, we can first understand the actual meaning of x and y coordinates and their relationship to specific values given in the word problem. We can also analyze the given scenario, find its corresponding point on the graph, and obtain specific information about that scenario from these coordinates. X and y, both of these coordinates mean something in this coordinate pair. We can use the method of numbers and shapes as one to transform numbers into shapes as well as to transform shapes into numbers. Graphs, geometry and algebra, you can alternate. You can transform into one another. So this is what this method is kind of talking about. Thinking about algebra as geometry and thinking about geometry as algebra. Let's do some step-up problems. Example 1. After a motorcycle goes to the gas station to fill up the tank, the relationship between the remaining fuel volume, Y in liters of the fuel tank, and the motorcycle distance traveled, X in kilometers, is shown in figure 1. This is figure 1. So the question is, how far away is the gas station from the starting point? And how much fuel was filled? Let's answer these questions together. We know this point has, we know the y-coordinate of this point is 2, but we are not sure about its x. So again, this is 6 for the y-coordinate. Here, now once we look at what x value these are both on, we see this is 400 kilometers. So the answer would be 400 kilometers. How much fuel was filled? All you have to do is look at the difference between the amount of fuel after filling it in and before. So 6 and 2, subtract, you have 4 liters. Step up. What was the pace of fuel consumption before the gas station, and what about after? Now this is a velocity problem again because it says pace. So we already know that this point has a coordinates of 400, 2 and 400, 6. And this x value that they both have is 400. And here it has a value of 600, 2. So we can find the change in y divided by the change in x. This is something we have not covered specifically yet, but I will be going over it quickly. So this is delta, a Greek symbol for change in. So we write it as change in y divided by change in x. This would be the first value of y minus the second value of y divided by the first value of x, which is corresponding to the first value of y, subtract the second value of x. And this will give you the slope, or k. This is equal to k. So if you have a notepad nearby, I recommend you jotting this down. This will be helpful, especially for later. All right, anyways, I'm gonna move on. So before the gas station, the motorcycle consumed 2 liters every 100 kilometers. And after, when x increases from 400 to 600, the amount of fuel decreases from 6 to 2 liters. 200 kilometers consumed 4 liters. Therefore, this motorcycle consumes, this does not make sense, should be the other way around, 2 liters every 100 kilometers. So it did not change. It was still the same consumption rate. Practice. The height of a plant after t days is y centimeters. I should say after t days after the day was planted. Function L reflects the relationship between y and t. Answer the following questions according to this functional graph. First question. How tall was a plant when it was first planted? This means that there were 0 days after the day was planted. Therefore, we look at this point right here, in other words, the y-intercept, and we have 9 centimeters. How tall is the plant after 3 days? After 3 days, we look at when t is equal to 3, and we mark its corresponding y value, which is 12. So 3, 12, that would be 12 centimeters. After how many days will the head of the plant reach 21 centimeters? Well, now we're looking with our y value. So we look at y, and then we see what is its corresponding t value, which would be which would be 12. So 12 comma 21, the answer would be 12 days. Linear functions and linear equations in one variable. Now we're going to be exploring the relationship between these two concepts. Discuss. What is the relationship between linear equation 1/2 of x plus 1 is equal to 0 and the linear function y is equal to 1/2 of x plus 1? I want you to think about that for a moment. What is their relationship? Well, from the numerical aspect, when the value of the dependent variable in this linear function is 0, the value of the corresponding independent variable is the solution of the equation. 1/2 of x plus 1 is equal to 0. But from the geometrical aspect, the x-coordinate of the x-intercept of y is equal to 1/2 of x plus 1 is the solution of the equation 1/2 of x plus 1 is equal to 0. So there's two aspects you can look at it in, numerically and geometrically. Let's answer these two questions. The x-intercept of y is equal to 2x plus 20 has coordinates blank, comma, blank. Therefore, the solution to 2x plus 20 is equal to 0 is x is equal to blank. The answer is negative 10, comma, 0 because this is when x is equal to 0. When y is equal to 0. All you have to do is plug in y as 0, which it basically has done here, and x is equal to negative 10. If the solution to the equation kx plus b is equal to 0 is x is equal to 5, then the coordinates of the x-intercept of y is equal to kx plus b are 5, comma, 0. So here's our conclusion. The relationship between linear functions and linear equations in one variable. Finding the solution to the linear function would look like kx plus b is equal to 0. From the functional value aspect, we can look at it as find the value of x and y is equal to kx plus b when y is equal to 0. These two things have similar meanings. Finding the solution to linear function kx plus b is equal to 0 from the functional graph aspect or the geometric aspect, we can think of it as finding the x-intercept of y is equal to kx plus b, or otherwise looking at its graph. We're going to do a final example too. The graph of linear function y is equal to kx plus b, where k and b are constants and k is not equal to 0, is shown. According to the information from the graph, the solution to this equation is, pause the video and answer on your own. Alright, so the correct answer would be A. Here's the analysis. The graph passes through 0, 1. Therefore, b is equal to 1. This is its y-intercept. Then points 2, 3 can be substituted into y is equal to kx plus 1. Therefore, k is equal to 1. So again, we learned this from the last lesson. Find the values of k and b first. The expression of the linear function is y is equal to x plus 1 and x is equal to negative 1. That's why the correct answer is A. Method summary. The key is to use the method of the undetermined coefficients to expand the expression of the linear function. Again, some practice from the last lesson. Class summary. Applying linear functions. Today we learned all about applying the graphs of linear functions to word problems, as well as the relationship between linear functions and linear equations in one variable. Today we mastered the application of graphs of linear functions, and we understood the relationship between linear functions and linear equations in one variable. Thank you so much for watching through Inquisitive Kids. If you enjoyed this video or if you found it helpful, please feel free to go down, click the like button, and to also share it with your friends if you think this would be helpful for them as well. Again, thank you so much for watching through Inquisitive Kids, and we'll see you next time.